Hello everyone, my name is Mukhlis ESHAMUDDIN and I'm a PhD student at the Chemical Engineering Laboratory Toulouse and Nereus. Today, I will be presenting to you my PhD subject, the Elimination of Organic Micropollutants by Moving Bed Biofilm Reactor MBBR and Nanofiltration, Role and Limits of Biofilm. Before I start my presentation, I would like to take this opportunity to thank the Leading Edge Summer Course Organizing Committee for accepting me as one of the participants in this course. Firstly, I will start with a brief personal presentation of my academic backgrounds before going into details on my PhD topic. My full name is Muhammad Mukhlis ESHAMUDDIN and I was born on the 19th of January 1996 in Penang, Malaysia. I was in non-C for 2 years, from 2015 to 2017, where I did preparatory classes for entrance into National Engineering School before graduating from Toulouse ENP NCSET in 2020 with an engineering degree in chemical engineering. During my final year, I had the opportunity to do an exchange for 1 semester at the Federal University of Santa Catarina, Florianópolis in Brazil, where I took courses related to biochemical and environmental engineering. And since mid-November 2020, I'm working as a PhD student at the Chemical Engineering Laboratory LGC Toulouse and Nereus. Moving on to my PhD topic, the objectives of my PhD can be divided into 2 parts. The first one is to elucidate the contribution of the native microbial systems present in the biological water treatment processes, in particular those with attached biofilms on the elimination of organic micropollutants. Previous works in LGC that are used as main references demonstrated that the main pathway of micropollutants removal is biodegradation via co-metabolism mechanism, with the majority of their degradation assumed by the biofilm on the carriers. Besides, they also found out that microbial populations seem to be unaffected by this approach. As the origin of this noteworthy performance remains undetermined, my aim is to investigate the functionalities and enzyme reactions that could be potentially triggered by the presence of micropollutants and dependent on substrates to micropollutants ratio. In order to do so, I will study the influence of selected operational conditions such as hydraulic retention time and organic loading rate on the microbial community's degradation capabilities. Once I've managed to identify the optimal operational parameters, they will be directly implemented in the wastewater treatment system that will be developed specifically to remove micropollutants. Throughout this thesis, a hybrid system consisting of a moving bed biofilm reactor MBBR and a nanofiltration system will be utilized. Several campaigns will be launched and executed using pre-treated wastewater from either wastewater treatment plants or hospitals around Toulouse. As you can see in the diagram below, the pre-treatment system will generate 2 streams, sludge and water. My PhD research only focuses on the water stream. The pre-treated wastewater will first enter the MBBR, where micropollutants will be eliminated by the attached biofilms on the carriers. The nanofiltration system is utilized to generate a recycling loop that will allow lengthening the hydraulic retention time of micropollutants, especially those that remain untreated in the outlet of MBBR. In this project, 25 organic micropollutants of various families with different physicochemical properties are selected. To end my presentation, I will present the project's current progress. Over the last few months, I did a thorough bibliographic research on the optimal operational parameters of MBBR systems to get a general overview and obtain fundamental components that will be useful for the implementation of MBBR system in my PhD. A list of 25 micropollutants has already been established, but it has not been finalized and validated by all members of the project yet. For the time being, I am monitoring the formation of attached biomass on the carriers in the MBBR. Characterization of biofilms will be done later on. Regarding the microbiological aspect of the thesis, in the near future, a bibliographic research on existing methods to characterize different functionalities and enzymatic reactions will be done. Thank you for your attention, and I look forward to meeting you virtually in the course for further discussion.